Hello everybody, I hope you all are doing great. So today I'm back with another interesting topic, that is measures of central tendency. What are the ways in which we could measure the central tendency? What is central tendency? We'll be discussing all of it here. So let's get started. A measure of central tendency is a summary measure that attempts to describe a whole set of data with a single value that represents the middle or center of its distribution. When we have a data, the data is obviously very large. In order to define the whole data, for example, when how many corona patients are there in India, for example, you can just take it like that. We cannot define them in numbers. We could better handle it with a central tendency. So we can take out percentage in that 10% of the population is infected with corona. Like that, you could just measure it. Okay, so it defines the whole set of data with a single value, giving a senseful thing to you. Okay, there are several statistical measures of central tendency or averages. Of course, you could call it averages also. The three most commonly used averages are arithmetic mean, median, and mode. So today we'll be talking about mean. What are the ways in which we could calculate mean? What are the different types of series? Okay. Coming on to the arithmetic mean or mean, firstly it is denoted by x bar. It is the most common measure of central data. It is the number which is obtained by adding all the values in the series and dividing them by the number of items. We are given suppose we are given data of 10 individuals, how much scores they have got. So we'll be adding all the scores and we'll be dividing it by 10 because we are having the data of 10 students. So that will be giving us the mean, the average of that particular data. When all the items of a series are given equal importance, then it is called simple arithmetic mean. Suppose I am giving equal importance to each item in the series, then we'll be doing it like this. But when different items of a series are given different weights according to their relative importance, it is known as weighted arithmetic mean. Suppose in some particular data, some numbers are given more weights because they are relatively more important. Their weight should be greater than that. When there is a vast difference in numbers, like there is a very small number and there is a huge number, so it is better to give weights to them so that we could have a better average. We could get a better average of what we are looking for. So the formula for the arithmetic mean is sigma x upon n. Sigma x defines the total, adding all the values which are there in the series, dividing them by the number of items there in the series. Now, see, we are going to discuss the methods of computing the arithmetic mean for three types of series. First comes the individual data series, in which only one item is given to us. Okay, we have a series of data for one particular thing. There is this discrete data series. We have two things in this. We have got value of two things for a particular series. Here we are given the items as well as frequency. And then comes the continuous data series. Here also we are given the items in the form of intervals like 0 to 5, 5 to 10, and then we are given the frequencies. So in continuous series we are given the intervals and then we are also given with the frequency, and discrete we are given the item number individually and as well as the frequency is given to us. Now, coming on to calculation of mean in individual series. See, there are three methods with which we could calculate mean. So, let us have a look at each one of them. First is the direct method. In this method, the formal definition of mean is used. What was that? Sigma x upon n. So, that is what it is. This is the simplest method and this is what it is used. Okay, so we'll be adding all all the items in that particular series, dividing it by n, that is the number of items in that particular series. Here we are talking about individual series, so we are having only one item. Okay, just keep this in mind. Then assumed mean method. See, what do you do in this method is you randomly select any value from the given items. You select any value and you take it as assumed mean. Okay, you have to assume that this is your mean. Okay, and then the formula comes in a plus, that a is the assumed mean, plus sigma d upon n. Now sigma d over here is d is equal to x minus a. X is the value in the item minus a, that is the assumed mean. I'll give you the example of this. Then comes the standard deviation method. First have a look at the direct method example. Suppose if I am having list of numbers 10, 10, 20, 40, 70. Okay. So the mean is simply the average using the direct method. So we'll be adding 10, 10, 20, 40, 70 and dividing it by number of items. How many numbers are there? 5. So dividing it by 5. So it will give us a simple answer 3030. This is the way in which we calculate it through direct method. Okay, this answer we'll be getting by direct method. Now coming on to the assumed mean method. See, we in assumed mean method we are having a pocket allowances. We are given with the pocket allowance. Okay, here I have taken 25 as my assumed mean. You have to randomly select any from the given series. You can select any number from them. Okay, then I am taking 25 as assumed mean. Now I'll be, for calculation of my d, that is the deviation. Okay, as the name only tells, deviation. How much the series number is deviating from the assumed mean that I have taken. Okay, so it will be x minus d. Okay, so 15 minus 25 will be minus 10. We'll have to deduct it and then we'll have to take the sum of d, because we are in the formula we have to take sigma d. So the formula x bar, that is our arithmetic mean, equals to assumed mean, that is we have assumed 25 over here, plus 90, that is the sigma d which is taken, upon 10, that is the number of items in that particular series. So the answer over here is 34. See, I've taken different numbers over here, but if you use any method, the answer should be same. Okay, if there are chances in which you are not able to use direct method, then you have to use assumed mean or the standard deviation method. Alright, and also it could be mentioned in the question that you have to do this particular question using this method. So that is a very different thing then. Now coming on to the third method under the individual series that we saw. Okay, again we have to find the assumed mean. See, in this method also what you have to do is, the formula for this method is assumed mean plus sigma d dash upon n into c. Now what is this d dash and c? In this method, d dash represents x minus a upon c. We have to take a common factor. When there is a common factor in the whole series, then we have to take that common factor and we have to divide it in order to find out our d dash in this particular formula. Okay, so now let us have a look at the example for the same. See, we are given the monthly expenditure and we have to assume any of it as our mean. So suppose if we assume 80,000 to be our mean. See, here the common factor will be 10,000. Of course you can say that because you know when we have a huge number, so in order to just simplify it a bit, it won't make a difference in the answer because we are simply dividing it in d dash and then multiplying it back in the formula. So it will not be making any difference. But when we have a common factor, that is, you know, making it difficult for us to calculate the single answer. So it is better to choose a common factor and divided by that particular common factor. Then it is better to use this standard deviation method. Alright. Coming on to the next series, that is the discrete series. The formula for the discrete series is x bar, that is denoting the arithmetic mean, is equal to sigma fx upon sigma f. Okay, so let us see how it is. Here the mean can be found, of course, again by three methods. One is the direct method, one is the assumed mean method or indirect method, and the last one is standard deviation method. Let us look at the direct method first. See, here we are given the marks obtained by, we are given we have a table of 5 over here. Marks obtained are 4, 8, 12, 16, 20, and number of students, that is the frequency, is given to us, that 6 students have obtained 4 marks, 12 students have obtained 8 marks, 18 students have obtained 12 marks, 15 students have obtained 16 marks, and 9 students have obtained 20 marks. So now you know what is the frequency, that is the number of students who have obtained that particular, who fall in that particular category. Now, for finding out mean in discrete series, first we need to multiply the x and f. So x is for the marks obtained and frequency is the number of students. So when we'll be multiplying them, okay, what will be the answer for sigma fx? After multiplying them, 4 into 6, 8 into 12, 12 into 18, 16 into 15, and 20 into 9. Whatever product we'll be getting, then we'll have to sum it up. So sigma fx is 756. So the answer for the same will be mean is equal to sigma fx, that will be 756 divided by sum of frequency, or you also call it n. It is one and the same thing, because frequency is simply defining the numbers. Okay, it is just defining that in that particular category there are more numbers. Either I'll write 4 and then 1. If it is an individual series, then I could just write 4 6 times, 8 12 times, 12 18 times. So in order to cut out those complications only, it has become easier for us to understand while having the frequency. Okay, otherwise it could have been noted in that format as well. So the answer for the same will be 12.6. So the mean over here is 12.6. That on an average, the marks obtained by these many students, by the 60 students in this particular class, is 12.6. Alright. Now, looking at the shortcut method or the assumed mean method, again we have to assume a mean over here, and here there will be one difference only, that is it will be sigma f dx. Okay, again you know what dx is. The key point here is this formula is often used when the variable are large in size or in fractions, and direct formula is not easy to use. Okay, so when the variables are very large, then we'll be using, or the direct formula is not easy for us to use, then we'll be using this. Again here we are given the x and f. These two will be given to us already. X is also given and frequency is also given to us. Now we have to assume any of it we can assume as d. So here I am assuming 30. Okay, so 30 becomes my assumed mean plus sigma d. What is d? D is equal to x minus a. So x minus the assumed mean, here 10, that is x minus assumed mean, not assumed mean minus x. So it will be 10 minus 30, which will give me minus 20, then 30 minus 30, 0, then 20 minus 30 again will give me minus 10, and then 40 minus 30, it will give me 10. This is my d. Now d into f, I have to multiply d into f, so I'll be multiplying it. 2 into 20 minus 40, 3 into 0 will be 0, minus 10 into 4 will be minus 40, 10 into 1 will be 10. Now what will be the sum of them is minus 70. So we are getting a sum here is minus 70, that is sigma FD. So it will be assumed mean minus 70 by 10, that is 7. Of course plus minus will give me minus only. So the answer for the same will be 23. I hope you are very much clear with these two methods. Alright, if you want to know how to calculate it through standard deviation method, if you want to solve more questions with me on this, you can enroll for my course. I'll see you there then. Have a great day. Goodbye.